In the previous chapter, we explained why we will probably never meet alien civilizations. The walls were biological, technological, statistical. Difficult problems, but in principle, problems. This is the part where the universe itself takes over the work of isolating us. The barriers we explore next are not engineering problems. They cannot be solved by better physics, faster ships, or longer lifespans. They are written into the geometry of space-time. They are the consequence of the universe being the kind of universe it is. There are three of them, three cosmological walls, each one larger and more final than the last. And by the end of this video, you will understand why 94% of the galaxies you can see right now are already lost to us forever, and why that number is rising every second. Astronomy is, fundamentally, the science of looking backward in time. Light travels at a finite speed. When you look at the sun, you are seeing it as it was 8 minutes ago. When you look at the nearest star, Proxima Centauri, you are seeing it as it was 4 years ago. The further away you look, the further into the past you see, and there is a limit to this. For the first 380,000 years after the Big Bang, the universe was an opaque plasma, hot enough that atoms could not form. Electrons and protons existed separately, and photons of light could not travel even a centimeter before being scattered by free electrons. The early universe was a wall of glowing fog. Then 380,000 years after the Big Bang, the temperature dropped below 3,000 degrees Kelvin. Electrons combined with protons to form neutral hydrogen atoms. The fog cleared. For the first time in cosmic history, light could travel in straight lines. That first liberated light is still traveling today. We detect it as the cosmic microwave background radiation, the CMB. It is the oldest light in the universe and the most distant thing we can ever see by any conventional means. The CMB is a sphere. We are at the center of it because every point in space is equally at the center of its own observable universe. The surface of this sphere is the moment of recombination, the wall of fog. We cannot see past it, not with better telescopes, not with better instruments. The light from before that moment does not exist as ordinary light. It was scattered into the plasma and lost to history. There are theoretical workarounds. Gravitational waves can in principle propagate through the pre-recombination plasma. Neutrinos as well, but the detection sensitivity required to use them as cosmic telescopes is decades, possibly centuries beyond anything we have ever built. For all practical purposes, the universe has a visual horizon, a wall of light that hides everything that came before. The first 380,000 years of cosmic history are not just unknown, they are unobservable. That is the first wall. Now we come to the wall that most people have never heard of, and that changes everything you thought you understood about distance in the universe. Everyone knows the universe is expanding. What is less well understood is what that means for the long-term geography of space. Galaxies are not moving through space the way a ball moves through the air. They are being carried apart by the stretching of space itself. The fabric between them is growing, and the further apart two galaxies are, the faster the space between them grows. This isn't an opinion. It is a measurement first published by Edwin Hubble in 1929 and refined to extraordinary precision by Adam Rees, Saul Perlmutter, and Brian Schmidt in 1998. They received the Nobel Prize in 2011 for confirming that the expansion is not just continuing but accelerating, driven by an unknown component physicists call dark energy. Here is the consequence that the textbooks rarely state plainly. There is a distance beyond which the space between us and another galaxy is growing faster than the light can cross it. Any light emitted from that galaxy today will never reach us. Any signal we send today will never reach it. Communication is permanently impossible. This distance is called the cosmic event horizon. Calculations based on the Planck satellite data place it at approximately 16.5 billion light-years from our current position. Compare this to what we can observe. The observable universe extends to a radius of approximately 46.1 billion years. That is the distance light has been able to travel since the Big Bang, accounting for the stretching of space along the way. Look at those two numbers. The universe we can see is 46.1 billion light-years across. The universe we can never reach or communicate with is 16.5 billion light years across. Doing the arithmetic, that leaves approximately 6% of the observable universe as gravitationally reachable. The other 94% is already physically beyond contact. We can see it. We can photograph it with the James Webb Space Telescope. We can study its chemistry, but we can never get there. We can never speak to anyone who is there. We can never know what it became. It gets worse. The cosmic event horizon is shrinking in terms of the co-moving distance it encloses. Every second, roughly 100 to 200 additional galaxies cross over the line from reachable to unreachable. They have not gone anywhere. They are still there, glowing the same as before. But the gap between us and them has crossed a threshold from which no message, no light, no information can ever recover. In the very far future, this process completes its work. Trillions of years from now, only the local group of galaxies will remain gravitationally bound to the Milky Way. Andromeda, our nearest large neighbor, will have merged with us. Beyond that local cluster, every other galaxy in the observable universe will have receded so far that even their light will be infinitely redshifted to wavelengths longer than the cosmos can transmit. They will, in any practical sense, no longer exist for us. Future astronomers on planets orbiting stars in our merged galaxy will look up and see only their immediate neighborhood. The history of cosmic structure, the evidence of the Big Bang itself, will have been erased from observation. The expanding universe is not just isolating us, it is erasing the evidence that the larger universe was ever there. The third wall is not a horizon. It is something rarer in science. It is a wall of matter itself, distributed in patterns the standard cosmological model says should not exist. For nearly a century, cosmology has rested on a foundational assumption called the cosmological principle. The universe, on large enough scales, should appear uniform. The same density of galaxies everywhere. The same structure in every direction. No favored regions, no preferred locations. A homogeneous, isotropic universe. The principle has been useful. Almost every cosmological calculation depends on it. The Friedmann equations that govern the expansion of space-time, the interpretation of the cosmic microwave background, the age of the universe itself. There is just one problem. We keep finding structures that should not be there. In 2003, a team led by J. Richard Gott III and Mario Urich at Princeton, working with data from the Sloan Digital Sky Survey, announced the discovery of a structure they called the Sloan Great Wall. It is a sheet of galaxies, a filament, and it stretches across 1.37 billion light-years of space. Read that distance again, 1.37 billion light-years. A single connected structure of galaxies longer than 3% of the entire diameter of the observable universe. And the Sloan Great Wall is not even the largest known. In 2013, Istvan Horvath, John Hakila, and Zsolt Begoli published an analysis of gamma-ray bursts across the sky, which revealed what they call the Hercules Corona Borealis Great Wall. It spans, by their calculation, between 6 and 10 billion light-years across, more than 10% of the diameter of the entire visible universe. Structures of this size are not predicted by the cosmological principle. They contradict it. The standard model says the universe should look smooth at scales beyond about 300 million light-years. The Sloan Great Wall is more than 4 times that limit. The Hercules Corona Borealis Wall is 20 to 30 times that limit. Either the cosmological principle is wrong, or there is some statistical mechanism that explains how clumps this large can form without violating it. The debate is still ongoing. The data is not. And here is where this wall becomes a barrier, not just a curiosity. The Sloan Great Wall is approximately 1 billion light-years from Earth. Even if every problem in the previous chapter were solved, every radiation hazard overcome, every relativistic engine perfected, traveling to the nearest end of the Sloan Great Wall would still require at minimum 1 billion years of subjective travel time. To cross it from one end to the other would take another 1.37 billion years. A civilization that wanted to explore this single structure would need to last as a continuous technological civilization for billions of years, longer than the entire age of complex life on Earth. And then there are the voids. Between the great walls and the filaments of galaxies are enormous regions called cosmic voids. These voids are not entirely empty, but they contain less than 10% of the average matter density of the universe. NASA estimates that voids occupy approximately 95% of the total volume of space. The largest void identified to date is roughly 1 billion light-years across. Consider what it would mean to travel for a billion years through nothing. No stars to refuel from, no planets to land on, no materials to repair your ship with. Just the diffuse hydrogen of intergalactic space, far too sparse to sustain any technology we can imagine. The cosmic web is a wall of matter when you need to cross matter, and a wall of emptiness when you need matter to survive. There is no version of this geometry that is hospitable to travel. By now you can see the structure of the problem. 3 independent walls. The first is optical. The cosmic microwave background hides the first 380,000 years of cosmic history behind a wall of plasma fog that no electromagnetic signal can penetrate. The second is cosmological. The accelerating expansion of space, driven by dark energy, places 94% of the observable universe permanently beyond reach, and the wall is closing in. Roughly 100 to 200 galaxies per second cross from the reachable region to the unreachable region. Every minute, thousands more become permanent strangers. The third is structural. The matter that does remain accessible is distributed in great walls and great voids. Structures so vast that even traversing one of them would require billions of years of subjective travel time. The Sloan Great Wall spans 1.37 billion light-years. The voids between them stretch a billion light-years across, with almost no stars or planets to support a journey. Together, these 3 walls describe a universe that is not just large, it is architecturally designed, in the strict physical sense, to isolate every observer in the cosmos from almost every other observer. This is not pessimism, this is geometry. The reachable universe is finite. It is small compared to the observable universe. It is shrinking, and the things we can reach within it are separated from us by distances that, even at relativistic speeds, would consume the entire lifetime of any biological species we know of. And yet, within the reachable region, there are still approximately 120 quintillion stars, roughly 2 billion galaxies, an enormous number of potentially habitable planets, possibly even other civilizations, hidden by the temporal walls we explored in the previous chapter. The walls of the universe are real, but what they enclose is still vast. The work of the next 10,000 years of human civilization, if we survive that long, will be to map and understand the small fraction of the cosmos we are allowed to touch. The rest is forever, not lost in the sense of destroyed, lost in the sense of disconnected. The light we receive from beyond the cosmic event horizon was sent before the wall closed. Future light from those same galaxies will never arrive. They have already, in a deep physical sense, left our universe. Look up tonight and remember this. The stars you see are still there. The galaxies you see through a telescope are still there. But many of them are saying goodbye in a slow motion, and our descendants, billions of years from now, will look up at a sky that contains only the Milky Way and its merged neighbor, Andromeda, with all the evidence of the larger cosmos erased. We are living in a privileged moment. Right now, the walls have not fully closed. We can still see the cosmic microwave background. We can still detect ancient supernovae from across the visible universe. We can still measure the structure of the cosmos in detail that future astronomers will be unable to replicate. If you want to know what the universe contains, the time to ask is now. The walls are coming. We have just walked through the walls that will isolate us from most of the universe. But not all walls are about separation. Some are about collision. Andromeda is on a direct trajectory toward our galaxy, and in roughly 4 billion years, the two will merge into a single larger object. What will the night sky look like from Earth in the years leading up to that collision? Watch when Andromeda collides with the Milky Way, what Earth will actually see, to find out.